Alright, this is chapter 19, which talks all about like chemical reactions. So we're going to start learning some different things about chemical reactions. Alright, so hopefully you remember we talked about chemical reactions or chemical changes a few chapters ago. And basically that's just where you change one type of, substance into another substance. And so we say that, the substances that we start with or that we react together, those are called the reactants. And then those new substances are called the products. Okay, and so we can write that relationship right here where we have reactants are going to, or we use the word produce, and we show that by an arrow. They're going to the products. So that's how we write everything. So you know how we spent all the time writing those formulas. So you always see like some chemical formula, arrow, some chemical formula. And you'll see more of that here in a few minutes. Excuse me. Okay, Antoine Lavoisier. Antoine Lavoisier was a French chemist. He's actually known as the father of modern chemistry. He is basically known, like, if we talk about, okay, so we have the reactants going to products, okay? What he's known for is he said, okay, well, if you have the total mass of the products, like let's say that we produce 10 grams, that means that we had to have 10 grams of reactant to start. What he said was that no matter how much product we had to have 10 grams to start with. We can't make new product, meaning that we can't just pull more mass out of the thin air. What we had to start with is what we end with, and what we start with is what we end with, and what we end with is what we started with. Mass cannot be created nor destroyed, any of that stuff. So that's kind of one of the big things that he did for us. We're going to be doing a lot with chemical equations. Chemical equations are just a great way to explain these chemical reactions that are happening. We're going to do several things with chemical reactions or equations. It's just a shorthand, so it's a way to show the formulas and the symbols all put together so that you can see those things. And we'll talk more about those a little bit as we go along. Okay, so the first thing we're going to do is we're going to talk about balancing chemical equations. Okay, so I've given you an example here. Balancing means that you take an equation, and I put in little spaces where you're going to actually, like you can see here, I put in a space here, and a space here. The goal is to put in numbers in those spaces, rather 1, 2, 3, 4, 5, whole numbers. You're going to put in whole numbers in those spots to basically balance this reaction, to make it so that each side of the arrow, because the arrow is the dividing line, okay, to make it so each side of that arrow has the same number of atoms on each side. We're going to fill in those spaces with what's called a coefficient. A coefficient is just a number. So, what I mean is, so what I do is kind of make myself a little table. So I start with making a list of what elements I have involved in the reaction. In this case, I have H and I have O. So and those are the two elements I have on each side. And they should be the same on each side. So if you just look at the reactant side, remember that this is the reactant side. This is the product side, just for reference. So I make a list of what I have, and the reactants and products should be the same. And then I start looking at how many I have. So in this case, I have 2 here. So 2 hydrogens. I have 2 here. 2 oxygens. I'm just making myself like a list. Kind of an inventory. Now, as you guys, everybody does this a different way. They can do it mentally. You can do it, some people need, the visual. It doesn't matter. I don't care. As long as, I want the final product. I want to know what are the numbers in the blanks. Okay, so over here you have 2 hydrogens. And then over here, notice there's nothing there, but of course we know there's a 1 there. We just don't write 1s for formulas. Okay, so now, look here. The goal is, now with our little tally sheet here, look, the hydrogens, 2 and 2. That's perfect. That's what you want. You want both sides of the arrow, or the reaction, the reactants, the products, to be the same. But look at oxygen. Oxygen's not good, right? 2 on one side, 1 on the other. So we need to fix that. The only way you could fix that, though, is to put a number in front of the like the hydrogen, the oxygen, or the H2O. Well, I look at this and I say I have a 1 over here, I have a 2 over here. So I would really like this side, the 1, to become a 2. So if I put a 2 here, now keep in mind that this is multiplication. So if I put a 2 there, this becomes 2 times 2 with the hydrogens. So now that makes, last time I checked, 2 times 2 is 4. And 2 times 2 with the oxygens. So now that's 2. Now that's the only bad part about this, is that you will have to start, you're like, well, one thing's perfect, but, you start messing with things and it messes up other things. It's kind of like, I don't know, it's one of those things, it's kind of like a Sudoku or something where you kind of have to play the game and, figure things out. And so if you're one of those puzzle type people, you might like this stuff. This sometimes is eraser, like pencil homework too, where you might have to try something, and if it doesn't work, flip your pencil over, erase, and try something else. But in this case, this one's not too bad, because now you're like, okay, well, my oxygens are okay, but my hydrogens are not. But I need to fix my hydrogen. Well, here, this just needs to become a 4, right? Well, if I put a 2 in this blank right here, 2 times 2 is 4. So that becomes a 4. So now everything's good. So the only thing I need to make sure now is I put a 1 there. A lot of schools just have you keep them blank. I don't know. I've went back and forth on it, and I think I've just decided that Hopewell has people put 1s in there, and I'm going to go ahead and have you put 1s in there too. So to balance this one, it would be 2, 1, 2. All right. We'll do another one. Okay. Alright, so again, I would make a dividing line. You have C, you have S. C, you have 1. S, you have 8. On this side, you have 1, you have 2. So far, your carbons are good, your sulfurs are not. So let's see, I'd really like to have 8 on this side. So if I put a 4 here, I changed my carbons to 4, and I've changed my sulfurs to 8. So my sulfurs are now good, but my carbons are not. So if I change, though, if I put a 4 on here, that would make that so it's 4. And so now I'm good, right? So the only thing I needed to make sure I do is put a 1 in front of there. So 4, 1, 4 balances that. And again, I did that really fast, so if you need to rewatch that or, whatever. Okay, let's try another one, more complicated. And I have some tips for you too. This is one of my tips. Start with polyatomics first. And my other tip is, if the polyatomic is on both sides, don't break it up. Like for example here, see how SO4 and SO4 are on both sides? Don't break it up into S and O. If you can keep it together, do it, because then it makes your balancing a lot easier. So like in this case, I have aluminum, I have Fe, I have SO4. It's going to make your balancing a lot easier. Okay, and so I have 1 aluminum, 1 iron, 1 SO4. I have 2 aluminums. I have, let's see, 3 SO4s, because see how there's a 3 on the outside there? That shows that I have 3 of them. And then I have 1 iron. So far, the only thing that is good in my entire balancing scheme is the irons. So again, the first thing I would mess with is the polyatomics. That's kind of my given, like, my little tip. I would mess with polyatomics first. I would leave hydrogen and oxygen till the end, if possible. Sometimes it's not always possible, but, you know, those are my little helpful tips from doing this forever. So let's see. I would start by trying to put a 3 there. That would make it now so that your SO4s would be 3. So that's good now. That changes, though, your iron here to 3. So that's not good. Okay. Now, you could go ahead and fix your irons, though, by putting a 3 there. So 3. Now you have to do is fix your aluminum because you need 2 on this side. So 2. Good. So now you got to do is make sure that all your spaces are filled. So 2, 3, 1, 3 balances that equation. Last but not least, ooh, this is a good one. Okay, this brings up one more point. Okay, so I have H, and I have H, so I gotta do that. I have PO4, look, I can keep that together, that's awesome, love that. Mg, O, and H already have taken care of. Okay. Alright. Now let's do the counts. Let's see. 3 hydrogens, 1 PO4, 1 Mg. Now, this 2 is like this. It's distribute, and this is a good point. There's no numbers inside, but just so I mention this, think about, like, there are numbers in here, so you get used to it. Like, these are ones, it's multiply. So 2 times 1 is 2. And 2 times 1 is 2. So that way you get used to. So if, like, there was a 2 next to, like, 2 next to this hydrogen here. So, like, this was O2H2. You would have had 4 hydrogens. Or 4 oxygens. It was multiply. Okay, just FYI. So in the future. Okay, now the other thing we need to point out is that, see how now I'm adding on, I have 2 hydrogens here. I got a lot of stuff going on. Sorry, let me erase some of this. Oh, I lost my... Okay, so I'm distributing this 2 to this H. So now I have 2 hydrogens. And I already have here 3 hydrogens. So when you have, see how there's a plus here? So I had 3 hydrogens here, I have 2 hydrogens here. You do exactly what this tells you right here. You do exactly what it says right here, which is add. So 3 plus 2. So right now I have a total of 5. Okay. Alright, and then the other side I have 3 Mgs, 2 PO4s, 2 hydrogens, and 1 oxygen. And again, this is where, you know, my years of doing this might help. I don't know. So, alright, so start with anything but, or start with the polyatomic. So start with the PO4. And again, if it doesn't work, you can erase and try something else. This way you do it with a pencil. So I have 2 on this side, 1 on this side. So put a 2 here. Okay, so that makes it so you have 2 of those. But it changes your hydrogens to 6 here. So now you have a total of 8. And this is why I kind of like the chart too, because you kind of can change things as you go along and visually see it. But hey, to each his own. Alright, so now, PO4s are good. Okay. Now, from there, I might go with the Mgs next. So I might go ahead and change this to a 3. Okay, so now I have the 3 I need. Now, that changes my oxygens. Now, look, that's 3 and that's going to be 2, so 6. So now I have 6 oxygens. And now this changes to 6. So now I have a total of 12. Let me pick a different color. Maybe if I can write over that with a different color so you can see a little better. So that's 12. Okay, so now Mgs are good. So the only thing I need to fix is my hydrogens and oxygens. And this is why, like, again, I leave that till the end because usually now I can fix that pretty easy. I need 12 hydrogens. Well, last time I checked, if I put a 6 there, 6 times 2 is 12. So that's good. And then 6 times 1 is 6. Look how easy that fell into place. And then just need a 1 there. So that's what I'm saying. If you kind of follow along and just do those steps where you go, polyatomic, then go with anything but hydrogen and oxygen, then a lot of times it falls into place. It doesn't always work that way, but now again, this is stuff you have to practice. If you just think I'm going to stare at it or wait till the test, you will, for the most part, there might be people who get it, but for the most part you won't. So practice, practice, practice.